Hi, I'm the Wannabe Coder, and welcome back to the Pac-Man in Python series. This is episode 1, and in this video, we're setting up the basics. We'll go over the Python version I'm using, the code editor, and the operating system, just to give you the full picture before we jump in. I'll also introduce you to the Turtle module, a simple graphics library that makes it easy to draw shapes and build games in Python. And then, we'll dive right into creating our game screen. Let's get started. Let's talk tools real quick, just so you know what I'm working with. I'm using Python 3.11 in this series, but anything from Python 3.7 or newer should work just fine. For the code editor, I'll be using Vim, mostly because I like how fast and minimal it is. But honestly, you can use any editor you're comfortable with. I'm running everything on Linux, but this tutorial works just the same on Windows or Mac. You might notice a few tiny differences, like how files open or how you install stuff, but nothing major. And just so you know, in this tutorial, I'm not going to cover how to install Python, Vim, or set up your system. I'm assuming you already have Python installed and a way to run your code. Alright, with that out of the way, let's start building our game screen. Let's begin by setting up our project folder. Create a new directory and name it Pac-Man. I named mine Pac-Man Tutorial, but feel free to call it whatever you like. Inside that folder, create a file called main.py. This will be our main game file. Once that's ready, open it up in your code editor, and we'll be all set to jump into the code. Just a quick heads up. In this series, I won't be typing out the code line by line. Instead, I'll walk you through pre-written code snippets, so we can focus more on what the code does and how everything works. With that said, let's take a look at main.py and see what's inside. This is our main game file, kind of like the brain of the game. It's the part that controls everything: the screen, the player, the enemies, and how the game runs. At the very top, you can see I added a comment in triple quotes. Comments are useful for describing what a file does. They help you and others understand the purpose of the code. In this case, I'm just noting that this is episode 1 of our Pac-Man in Python series, made by the Wannabe Coder. I also explained that main.py is the starting point of the game. It pulls everything together: the visuals, the logic, and the game loop. After that, the first real line of code is import turtle. This brings in the turtle graphics module, which we'll use to draw the game screen and move our characters around. Importing a module gives you access to all of its built-in tools and functions, so you don't have to build everything from scratch. Turtle is a simple and beginner-friendly graphics library that comes built-in with Python. It lets you create drawings and animations by controlling a little on-screen cursor, almost like moving a pen around the screen. Even though Turtle is usually used for basic graphics and learning exercises, it's powerful enough for building simple games, like the Pac-Man clone we're making. We'll be using Turtle to draw the game screen, create the maze, move the player, and animate the ghosts. Now we're back in the code editor, and it's time to set up the game screen. To keep things organized, we're going to define a function called init_screen that will handle the setup for us. Technically, we could just write all the screen code directly in the main file, but wrapping it inside a function keeps our code cleaner, easier to manage, and reusable if we ever need to reset the screen later. So, first, we define the function by writing def init_screen. Inside this function, the first thing we do is create the game window. We create a variable called screen by calling turtle.screen. This gives us a new turtle graphics window, the space where our entire game will happen, including the player, the maze, and the enemies. Next, we turn off automatic screen updates. We do this by calling screen.tracer with 0. By default, Turtle tries to update the screen after every single little movement, which can make animations look slow or flickery. Turning off automatic updates lets us manually control when the screen refreshes, making our animations much smoother. After that, we personalize the window by setting its title. We do that using screen.title with your custom title inside quotes. You can write anything you want here. Then, we set the size of the window. We do this by calling screen.setup with width 1000 and height 800. This defines the overall space we'll work with. Later on, we might adjust these numbers depending on the size of the maze grid we build. Next, we change the background color to black. We set this by calling screen.backgroundColor and setting it to black. This matches the original Pac-Man arcade style and helps the player and maze elements stand out clearly. And finally, we return the screen object by writing return screen. Returning it lets us use the screen later in our main game code to draw, update, and control everything that happens. Now let's talk about the game loop, the heartbeat of our game. We define a function called game_loop, and it takes one parameter, screen. So what exactly is a game loop? It's the part of the game that keeps everything running in real time. It refreshes the screen, updates the player and the enemies, checks for collisions, and handles user input over and over again, many times per second. Without it, the game would just freeze after drawing the first frame. Nothing would move or react. Now, why do we pass screen into the game loop? We pass it in because the screen was created earlier inside a different function, initScreen. By passing it as a parameter, we make sure the game loop can access and control the same screen without relying on global variables. This keeps our code modular, clean, and easier to update later if needed. Inside the game loop function, we call screen.update. But why do we need to manually update the screen? Let's connect this back to something we did earlier. In the initScreen function, we called screen.tracer with 0, which turned off automatic screen refreshing. That means Turtle won't redraw the screen after every little movement. Instead, we control exactly when the screen refreshes by calling screen.update ourselves. This gives us much smoother animations and better performance, especially when there are a lot of moving pieces. So even though the game loop only has one line for now, it's already laying the foundation for everything that will happen next, like player movement, enemy behavior, collisions, and scoring. And don't worry if this feels a little abstract right now. Once we start adding moving characters and interactive elements, the purpose of the game loop will become really clear. Now that we have our building blocks ready, it's time to connect everything together and actually start the game. We do this by defining a new function called main. The main function is the central place where we set up the screen, start the game loop, and launch the game window. It controls the full flow of our game, all from one place. Inside the main function, the first thing we do is call initScreen. Remember, initScreen is the function we created earlier to set up the turtle screen and return a screen object. Until now, we hadn't actually used that function yet. We only wrote it. By calling initScreen here, we're creating the game window and starting it up, right where it belongs, inside the main function. We want to call it here because the main function should always be in charge of setting up everything important at the start of the program. This keeps the code clean, organized, and easy to manage later as the project gets bigger. We store the result in a variable called screen. Now, screen holds the turtle screen object that we'll use for everything: drawing the maze, placing the player, refreshing the graphics. All of it happens on this screen. Next, we call the game loop function and pass in the screen we just created. Remember, the game loop is the engine of our game. It will control how the screen updates over time, refreshing player movements, ghost movements, and all the action. And very importantly, it's the same screen we created with initScreen. We're passing it into the game loop so that when screen.update gets called, it refreshes this exact game window. Not some random new screen, but the one we just set up. After starting the game loop, we call screen.mainLoop. MainLoop is a built-in turtle command that keeps the window open and the program running. Without calling MainLoop, the window would just open and immediately close, and we wouldn't see anything happen. MainLoop tells the program, keep the game alive, keep updating, and wait for player input. Finally, at the very bottom of the file, we add a small condition. We write, if name equals main. This just means, only start the game if we are running this file on its own. If the condition is true, we call the main function, which starts the game. In our main.py file, if we run it on its own, like typing Python main.py in the terminal, Python sets name to main with double underscores. The condition becomes true, and the game starts. But if we import main.py into another script, by writing import main, Python sets name to main without underscores. In that case, the condition is false, and the game won't start automatically. The file will just quietly provide its functions to the other project. This is a good practice to protect bigger projects later and keeps our code more flexible. So by connecting everything inside the main function, we now have a complete starting point for the game, with the screen set up, the game loop running, and the window staying alive. Before we move on, let's quickly review what we built so far. First, we created the init screen function. This function handles setting up the game window. It creates the screen, sets the size and background color, adds a title, and turns off automatic updates for smoother control. Then, we made the game loop function. This function is responsible for updating the screen manually. It's simple right now, but later, it will manage all the real-time actions, like player movement, ghost movement, and collision checks. After that, we wrote the main function. The main function puts everything together. It sets up the screen, starts the game loop, and keeps the window open so the game can run properly. At the bottom, we added a check, if name equals main, which makes sure the game only starts when we run this file directly, and not when it's imported into something else. So at this point, we basically have the core structure of the game ready. We have a screen setup function, a function to handle real-time updates, and a main function that connects everything in the right order. Now, let's run the program and see what we have so far. You should see a window open with the title we set and a black background. There's no player yet and no maze, but this is the foundation we'll build everything else on. So at this point, we've got our game window up and running, and the core structure of our Pac-Man game is in place. In the next episode, we'll start building the maze. We'll define its layout and draw it right onto the screen, one block at a time. If you found this helpful, a like and subscribe would really help support the channel and make sure you don't miss what's coming next. I'm the Wannabe Coder. Thanks for watching, and I'll see you in episode 2.